Okay, very good morning. So let us continue with where we have left yesterday. So yesterday we were discussing about the project scheduling and tracking. So I discussed about one of the techniques where we spoke about the PET charts and the program evaluation and review technique charts. We are going to specify which and the activities which are generally occur during the project development, and in this we are going to specify so how many weeks, how much time it is going to take, means what is the elapsed time, and also the effort in the sense how many persons are required per month or week, whatever is there we are going to specify in this. Okay, next type of charts which we have, which is also used for scheduling purpose, is about the Gantt chart. So in this Gantt chart, it is again a graphical representation which specifies the start date and end date of each software engineering task. Means whatever the task which you are supposed to perform, so you're going to specify what is the beginning date and what is the ending date of each software engineering task. And it is like an UML sequence chart. So we have discussed about the sequence diagram, where the sequence of activity means in the sequence diagram we specify which object is going to interact with another object. So what are the type of objects which are going to participate. I mean, it generally discuss about the dynamic behavior of the system. So it looks like the Gantt chart looks like the sequence chart. So on the x-axis, on the one axis it shows the time, on the other axis it shows the activities that are to be performed. Okay, so now note one point, that it is not just used only for in this software engineering purpose. In other areas also, like the management or any area where some tasks are supposed to be performed, so we are going to use this Gantt charts. So in this see here, if you observe now, this is one Gantt chart, so where you have a solid black line which is representing the requirements activity. Under the requirement activity, so we have the requirement gathering, which is an halo halo bar is there, and also we have a review, and also the specifications, and also the specification review. The end of that review means it starts from week 0, means the beginning, and at most at up to 10 weeks it is going to perform. And then the designing phase is going to start. Under the designing phase, okay, so the designing is done from week 12, week 10 to somewhat week 18 it is going to perform, and the final review is done. So when the designing is done, see, the testing also is also started in this here. Now note one point here, that so it will specify which activity will follow which activity, and at the same time which activities will run in parallel, which will run in sequential, it is also been determined. Means here the requirements is done. Once the requirements is done, then the designing is starting, and while the designing is actually going on, the test plan development is also have been started. And once the designing is done, they are done with the designing, the implementation has been started, and when the implementation is going on, the inspection is also started. So the horizon, these bars are actually telling you which activity is going on, and which activity will follow which activity will occur sequentially, and which activity will occur horizontally, parallelly, it is going to specify. And if you go for this time axis, it is going to say, so at which point it is going to start and which point it is going to end. Means you can have sometimes in some Gantt charts you have the dates also. In some Gantt charts you will come across with the dates also, specific dates. So if I show this here, see here in this Gantt chart, some Gantt chart is again the construction of a house, so 20 days duration. So starting date is 13 February 2014. Okay, So 13 February 2014, and some date is also given. And in this chart, actually the bars are going to specify so which where it is starting and where it is running. So what are the different activities which are being performed. Means it's not just meant for only computer science, but also it is can be used in other areas of management as well as engineering. So where we can schedule, where we can plan and schedule which activity will perform, what activities will perform, and when they are going to start and when they are going to end. So what is the starting date, ending date, everything you can specify using this Gantt charts. Okay, so that is about the Gantt charts here. This chart does not show the allocation of the people. Of course, it is not going to show you the allocation of the people. So it doesn't show you the allocation of the people or to the task, nor we have the chosen to show the breakdown of implementation. Means, of course, some allocation of people, how many, what is the effort is not shown. So in one single term, what I can say here, of course, it is this paragraph is given regarding a particular example here, but in one point I can tell you that it is not showing you the effort. Means how much, how many people are required, how many people are required, it is not shown. But here in the PET chart, it is shown that how many people are required per month, or you can say per week, and how much time it is going to take. But it is not specifying when it is going to start and when it is going to end. But of course, in Gantt, in PET charts also, what you can do here is you can specify the starting date and ending date also. In this also you can specify when it is going to start and when it is going to turn, and what is the total time and what is the total effort which is required to complete the task. We can show it here. Okay. Then after these two types of techniques which are in general used for scheduling the project, means to specify the schedule of the project. So we have the end value charts. This end value charts is the amount of work, means they specify the progress of the work, means how much amount of work has been completed, measured according to the budget effort that the work was supposed to consume. Means budgeted effort means how much end value amount of work has been completed, measured according to the budgeted effort of the work that was supposed to consume. Means how much budgeted effort, means how many people have been assigned, so how the budget is running on, whether it is on track or not, it is going to specify. And it also called as budgeted cost of work performed. And it is also, the end value charts are also called as an budgeted cost of work performed. As each task is completed, the number of persons per month originally planned for the task is added to the end value of the project. Means whenever the task is completed, the number of persons months originally planned for the task is added to the end value of that project. So here, however, the task may be completed late and may take more effort than planned. Means sometimes what happens, whatever you are planning, so they may take more effort. Means sometimes more people are required, more time is required. So an end value chart can be used to measure the extent of to which the project is behind schedule and over budget. And also you can see here in the by studying this chart, you can specify so how much extra effort is been used for the project, as well as how much time the over budget has been actually done here. So it has three curves. The end value chart in general has three curves. The first curve is actually the budgeted cost of work schedule. The budgeted cost of the work schedule. So this is a planned amount of effort that was supposed to have been expended by any point in time. Means it is a planned amount of effort. So it is computed by examining the cost estimates on the Gantt chart. So how it is computed? By examining the cost estimates on the Gantt chart, it is going to be computed, and it is shown by the solid curve. Now here it is. So in this diagram, so the solid curve which is there, it is actually specifying you, the solid curve is specifying you the budgeted cost of the work schedule. Then we have the end value, that is the budgeted cost of the work performed. the budgeted cost of work performed means how much work is been performed. So this is shown by the dotted curve, and it is shown with this dotted curve here. It is shown by the dotted curve. Okay, then the third one is the actual cost of work performed so far. So how much work is performed means this is shown by the dashed curve. And at any point in the project, you can tell how far behind the schedule you are by measuring the horizontal distance between the end value curve and the budgeted cost of the work schedule. So you are going to find the difference. The horizontal difference actually shows you the how much time means how much time you are behind the current work schedule there. The project is 6 weeks behind the schedule at week 23. See here, it is at week 23, it is 6 weeks behind. And also the vertical distance actually, so because on the y-axis effort persons per month is specified, on the x-axis the elapsed time is specified, and the vertical difference actually will tell you the completed work in 2 persons per month or budget at week 23. Means you are requiring 2 persons per month extra for completing the work at, means here extra in the sense you need to go for an extra payment, extra effort you are going to specify. Okay. So this is what actually is can be studied at using this end value chart. So that completes about what type of project scheduling and tracking tools are used for in the project for actually designing the schedule as well as for tracking the project respectively. Okay, so next that actually completes the entire fourth unit. Actually almost the fourth unit has been completed. Then we have then we need to start about the third unit. Today I am going to start the third unit now and discuss you about the designing process. See, we are not going actually in some order. Actually it is purposefully I have just changed the order here. Why? Because the designing actually has somewhat complexity. So slowly we will understand each and every technique which is used under designing. So already we are done with the requirements gathering. First of all, just to review, just to revise what we have studied until now is what we have studied until now is, first of all, we understood what is software engineering. Then we discussed about then we have discussed about what is the requirement, what are the different activities which are involved in the software engineering. Then we have discussed about how to gather the requirements, how to build up the requirements document. Then we have discussed about the various UML diagrams for modeling, what type of diagrams we generally use. And then we discussed about the user interface designing, how to design the user interfaces. Okay, then we have discussed about after discussing these user interfaces, then the next phase is actually after the requirements gathering specification is done, the next phase actually is designing. So I just skipped the designing phase, and we went and we discussed about the testing techniques. What are the techniques which are required for testing the project? We have discussed that. And after discussing the testing here means thoroughly, so after the development means after the implementation, because once the design is done, the next thing what you are going to do is the designing. So under designing, you are going to design the entire project at the core level. After designing that, you are going to implement it. And once the implementation is done, you are going to thoroughly test your project. Once the project testing is also done, then it will go for the usage. For it is deployed, and it will go to the implementation stage where the client or the user is going to use your project. So what we have just skipped is about the designing there. How actually the designing is done? What is actually the designing? So what are the different rules which we generally follow under designing? And here also we will certainly discuss about the various patterns, the common patterns when we generally use while designing the project. So one by one from today, we are going to discuss this designing concept uh, here. And first of all, let us discuss today what exactly is designing. Okay. Then, in context to the software design is a problem-solving process whose objective is to find and describe a way to implement the system's functional requirements. Means here it is a problem-solving process. Means you are going to solve uh, the problem. You are going to solve the problem. Which problem you are going to solve? So your objective is here to find and describe the way to implement the system's functional requirements. So where you have gathered the functional requirements, you have gathered the functional requirements using the requirements phase. Okay, means functional requirements are those requirements which are offered by your system and which are used by your which are available for the users to use them. Like I have given you the example that if you talk about an ATM machine, so what I have done in the requirements, I want a machine which can disperse money. I want a machine where I can check my balance. I want a machine where I can transfer the money from one account to another account, etc. So functions are required. I said. Now what you are doing? Now you are going to design the machine. You are going to taking those requirements. You are going to design the machine here. So it is whose objective the design is a problem solving process whose objective is to find and describe a way to implement the system's functional requirements. So you are going to implement the system's functional requirements here while respecting the constraints imposed by the quality, platform, and process requirements, including the budget and deadline, and while adhering to the general principles of good quality. So what does it mean here? So you need to respect the constraints imposed by the quality. So we have discussed about the quality requirements also, not just the functional requirements. We discussed about the quality requirements also. We need to meet the quality requirements. The same example which I have given in your classes, I'll just repeat. I want to withdraw the amount from ATM. Very good. But at the same time, what constraint I'm imposing there? The quality constraint which I'm imposing, I want the money to be dispersed in less than 20 seconds. So that is a quality which I require. Now, so I need to plan according to meet that quality, and I am specifying a particular platform on which it has to run, and describing. I'm stating some process requirements also, like the budget and the deadlines when it is required, in how much budget I want you to develop the software, and while adhering to the principles of good quality. So I want the good quality software. So a designer is faced with a series of design issues. In general, what happens here? The designer, now you all peoples are designer. Now and then what you are going to do? You are going to certainly design your project. So you are going to face a lot of designing issues here. So which are the sub problems for all our design problems? So here there are several alternative solutions which are generally known as options. So which option which you are going to choose? Now it all depends now here, because every solution, every option which you are going to choose will have some pros and cons. So certainly we will have some advantage, pros and cons here. So the designer make design decision to resolve each issue. Okay, so this process involves choosing what he considered to be the best option from among the alternatives. So now you need to specify, as I just said, you are having several solutions, several options for that particular design. Now you need to judge, you need to come to a solution, you need to come to a confirmation to choose a particular design, and you are supposed to give a rationale, the reason behind choosing a particular alternative. Why you have chosen that alternative? What made you to choose such alternative here? Okay, So each design decision, the software engineer uses all the knowledge he at his disposal. So whatever the knowledge which he is having at his disposal, he is going to use, including the knowledge of the requirements. So what knowledge you are going to use? You are going to use the knowledge of your requirements, your knowledge of the design as created so far. So far, if you have created some design, you are going to use that knowledge, the knowledge of the technology, because already we discussed previously that you need to identify, you need to think whether are you mm, mm, able to develop the particular system in the available technology or not. That knowledge also you must have, and also the knowledge of the software design principles. So you need to have the knowledge of the software design principles, the design principles which you are going to discuss very soon in the coming classes, and the best practices, and about the knowledge of what has worked well in the past. Means you need to have, because the experience, the past experience will play a vital role. So what knowledge, then you need to discuss, you need to have the knowledge of what has worked well in the past. So the past knowledge will also help you to take a good decision here. So when the decision is made, again some new issues will be raised. Obviously some new issues will be raised, okay, because there is no suitable choice to resolve a given issue. In that case, the designer may go back to revise the previous decision. Sometimes, when new decisions have been new um, issues have been raised, you need to go back and revise your previous decision, or else propose the requirements to be changed. Then, so you need to ask for the change in the requirements, or you need to revise the decisions because the new issues have been raised there. Okay, and now as I said that when there is no single alternative for you to choose, because we cannot say the single best alternative when dealing a particular design issue. Several alternatives may have the opposite advantages and disadvantages with no clear winner. As I just said, uh, no each option will have its own pros and cons there. So here one example is given that a thin client system might result in software that is simpler, whereas a fat client system might result in software that means more efficient of use of CPU and network resources. Both might be seem equally good. Now we have the thin client system, a flat client system. I hope you are aware of what is a thin client and what is a fat client. So thin clients, just to share you with the knowledge, what is a thin client system? In a thin client system, there won't be a CPU or any processing which is done at the client area. All processing is done at a centralized system. Only the clients, the thin clients, just will have the monitor. They have a small keyboard, mouse, and a small connector to the centralized CPU. Every process is done at the centralized CPU. That is the thin client. Whereas the thick client is like the fat client, or the thin client is like the systems which are like your desktops. Each individual is having its own processor, own CPU, own processor, own storage area, but all are connected to one another. Now you can think about, so as per budget, as per requirement, which system is best, the thin client or the thick client or the flat client? That all depends upon, because each is having its own advantages and disadvantages here. So when evaluating alternatives, different designers have different knowledge. Now again, this is also a problem, an issue. So no two people will have the same type of idea. Why? Because according to their past experiences, according to their knowledge, different designers will have the different knowledge and ideas, and therefore they will tend to reach the different conclusions. So I may come with a different conclusion, you people may come with a different conclusion. Again, it would be a problem. So no two designers will rarely come with an exact solution. So the space of possible designs that could be achieved by choosing different set of alternatives is called as a design space. So the space of possible designs. So what it is said here, the space of possible designs that could be achieved by choosing different set of alternatives is known as design space. So here, say here, So you are going to develop a system. If it is a monolithic system, then no problem. Monolithic it is single user, nothing. No, a single user. Okay. Showing the alternative design of resulting different choices when making a decision. So if it is a monolithic, no problem. If it is a client server system, then you need to think about whether it is a fat client or thin client. When it is a fat client, separate user interface layer for the client or no separate user interface for a client. So if it is a separate user interface layer for a client, then programmed in Java, programmed in VB, programmed in Visual C++. So different interfaces. So same interface, no separate interface, then no problem. Then different interfaces, then different languages. See the options, how the options have been raised here. So this all depends upon the solution, the option which you are choosing here. So different set of decisions lead to different products. So you have different set of decisions when they lead to different products here. Okay. And now you should try to explore different paths to the design space, investigating the consequences of choosing different alternative when the major issues arises. So you need to go with the design space. As I told you that in the design space, different design alternatives have been specified. Now you need to go through those design space and think about which alternative is best. Okay. Now, next point here to discuss is about, although there might be several ways to produce a good quality system, some design issues are critical. For critical decisions, bad choices will lead to a poor system. So sometimes there might be several ways to produce a good quality system. Some design issues are very critical. There may be different options, but some design issues are very critical. You need to very what I can say, that you need to handle them very carefully. If not, the bad choice will lead to a very poor system. If you are making a bad choice, then it will lead to a very poor system there. Then you cannot. It will be hard for you to again rectify the same system again there. Now, for example, here imagine that you are at a very early on your design, you choose not to have separate user interface for the rest of the system. Such a design would greatly constrain your ability to achieve a flexible, maintainable design. And for example, it would become very harder to provide web-enabled version of your system or to internationalize it. Means if you are not making a decision like here, if you are not choosing to have separate interface design, for example, if same interface design, then what happens here, you may not have you may not go for you may not have an option for web enabled version of your system, or to internationalize it also it may be come with a problem. Means the earlier decision will make you very rigid, it cannot be very flexible. So just an example is given here. So each decision should be recorded along with the reasoning went for making decision. This point already I have stressed earlier in the class, that whenever you are making a decision, it should have a proper rationale. Rationale in the sense, the reasoning. Why you have made that decision? What made you to take that decision? What made you to choose that particular choice is also very important. So entire record of these decisions are being documented. As I told you yesterday, I told you the configuration management team will be there. So they are going to record the changes and also the reasoning, everything they are going to maintain there. So why you have made that decision, what made you to make that decision also is considered. Then you come to a final conclusion here. Now, what are the parts of the systems we have? So part of the system. So it is the time to know some terms that are helpful in here. Already we had discussed these, but formally let us discuss these remaining. Formally let us discuss them again. Now, first thing is here is a component. What is a component? It is any piece of software or hardware that has a clear role and can be isolated, allowing you to replace it with a different component with equivalent functionality. So what is a component? Any piece of software or hardware that has a clear role. Now it is having a clear role. and can be isolated. So it is isolated and allowing you to replace it with a component equivalent with a different component with an equivalent functionality. What is that? For example, you have a hard disk. So it is a component. So what you can do, you can replace it with another hard disk with equivalent functionality. A battery is there. You can remove the battery and you can replace it. A software is there. You can remove that software and you can actually replace another software which works has an equivalent functionality. And many components are designed to be reusable. This point also we have discussed many times that the components which you are actually designing generally are the components which we generally design should have an idea of reusability. So you should think about the reusability and design the components. So the designer should think about the reusability. Okay. Or sometimes the other cases they perform a specific purpose. They perform a specific purpose, means providing user interface of a particular system. So when it is providing the user interface of a particular system, so excuse me. Okay, let me continue. It's like an advertisement in the between a serial when it is going on. I hope you have listened to that. It is telling about the exhibition which is running in the Kakinada. Okay. Fine. Let me continue. Now, many components are designed for reusability, but in other cases, it is like it is meant for a specific purpose, specific functionality only. Providing the user interface for a particular system is not reusable because it is meant for only that system only. But whereas in case of framework, which we have discussed earlier in the beginning classes, it is a kind of component, so which can be used for the frameworks generally used for attaching another components and make them working together. So other components include the source code files, executable files, DLLs, the dynamic link libraries, and databases. Some components such as source files only exist at compile time. Other components such as certain data files may exist only at runtime. So sometimes they exist at runtime. Like for a simple example, packages in Java, they are actually components. Header files in C, they are the components. So they are reusable. So the dynamic link libraries which are used by your system, so all your operating system, all comes under the various components here. Next, a module. What is a module? A module, a component that is defined at a programming language level. A component that is defined at a programming language level. Means, for example, classes, packages, or modules now. Okay, classes, packages comes under the modules. So like it is like a function, a module, a package, which is having collection of classes, interfaces, okay, methods, okay. So these modules in C, the programming are the files and the functions, the files and the functions. Next, we have the system. System. What is a system? A logical entity having set of definable responsibilities or objectives and consisting of hardware, software, and both. So a system is a logical entity. It says that it is a logical entity having set of definable responsibilities. In the sense, every system is having a responsibility or objectives, and it is consisting of hardware and software or both. So it has both hardware and software here. And a system has a specification that is then implemented by the collection of components. So every system is having some specification that is then implemented by a collection of components. The notation of the system can be extended beyond hardware and software to include also people, business, process, organizations, natural phenomena that work together to achieve something. So the notation of the system can be extended because I told you what is a system. See here, the definition which I have given you in the class is now is applicable here. So I said that a set of different components working together to perform a specific task is called as a system. Now, what components there are required? What components are there? The components, like if you are taking your computer, you are having a CPU, you have a monitor, you have a keyboard, you have a mouse. Okay, you have a hard disk, you have a processor, RAM, etc. But to operate them, also people are required. Your power is required. Table, desk, everything is there. All this comes under a system, because when you are having a person, if a person is not there to operate your computer, it can't run by itself. Okay, so all this, the notation of the system can be extended beyond hardware and software. That's what he is saying here, that it can be extended beyond hardware and software. It is not just the hardware and software components. It includes the people, the business processes, organizations, natural phenomena, etc. Everything comes under the system. And it continues to exist even if the components change over the course of time or replaced by the equivalent components. The system generally continues to exist even even some of the components have been replaced in the course of time. Next, we have the subsystem. What is a subsystem? A system that is a part of a larger system and which has a definite interface. A system that is a part of larger system and which has a definite interface. Okay, means I told you the entire system is divided into subsystems, and subsystem is having a predefined role or a task. Okay, it is performing one role. Like in our human body, see, if your entire human body, if you consider as a system, now each organ, I can call it as a subsystem. So your digestive system is a subsystem of your human body. Your nervous system is a subsystem here. Okay, likewise, if you go for a computer, your monitor is a subsystem. Your CPU is a subsystem because it's composed of different kinds of parts there. Like here, one example is given that Java user packages to implement subsystems. Individual classes may also implement particular low-level subsystem. So Java's user packages, so they used to implement the subsystems here, and the classes may be used to implement the particular low-level subsystems. So in software engineering, the requirements analysis process determines the responsibilities of the system. So this specification determines the interfaces of any component built to implement a system. The design process determines how the components will be implemented. So here in the specification, you are telling what components are required to build up a system. And now in the design process, you are telling how they are implemented. So that is a difference between the requirements gathering and the designing here. So in the requirements gathering, you are specifying what components are required, what are required to run the system. Now you are telling how they are implemented. Now you are telling how they are implemented here. So here is a UML notation. See here, a system is there. Now it is a UML class diagram which it is having a system is there. Each system is having its name and the responsibilities it is going to perform. And a system, it is a generalized term. So this actually shows you the specialization, means this triangle shows you the specialization. So which says the subsystem here, means inheritance relationship is shown here. The generalization specialization relationship is shown here. At the same time, you have this association also. The system is composed of several number of subsystems here, and each system is implemented using different components. Different systems will be implemented using one or more components, and each component will having one name, and each component is made up of 0 of 1 different components there. See, this association is again shown here, which is specifying each component is actually made up of 0 to 1 different other parts. 0 to 1 components are made up of different parts, and again the component may be a module or a framework. And what is a module? It is defined at the programming level. Okay. Note that for much of the decisions that follow here, we will be talking about the designing the modules. Of course, that is about what we are going to talk later on. Now, next here is about what is the top-down design and bottom-up design. So this I will discuss briefly in the next class. Already you know about that, what type of designing we have. Then I will talk about the principles leading to the good design. So we have 12 different principles we have, which requires very detailed study on how we are going to implement these means how to design the system, what are the each design principle is saying. So these are all things which we will discuss in the coming class. Just wait, everyone. Okay, fine. So that's it for today. So see you tomorrow in the college, everyone. Hopefully we will have the physical classes from tomorrow. See you soon tomorrow. Take care, everyone. Have a nice day. God bless you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.